Alright, so lesson 1.4, factoring, more factoring stuff.
Subscribe.
So today we're going to learn about expressions like this. I got my pencil. Lots of times we've been dealing with factoring something like this. Say 7x plus 6. And when this coefficient out front is a 1, it makes the factoring real easy because you already know the first and third positions are going to be x and x, right? And all you have to really do is figure out these two positions. Well, the problem becomes a little bit harder when we come along and change that to a 4, for example. That makes things a little bit more hard or more difficult. But what it means is that, well, when we have something like 2x squared and plus maybe 10x or something like this, minus, I don't know, I'm just making this up right now. When we have something like this, then the first and third slots are not as easy. It doesn't mean it's terribly hard, but they're not as easy. So this is where our first and third numbers come. Now, here's the thing to remember. This factor right here always gets the first and third. And then this factor over here always gets the second and the fourth. You see? So you're going to find two numbers from this, and they go in right here. From this number, two factors. And this number, you have two factors here and here. Alright, that being said, it's not always that difficult to do. So let me show you the lesson I have prepared for you. What are you laughing about? Oh, that's something else. That's the wrong lesson right now. I gotta get the wrong. That was something I was doing on the side there at lunch. My document. Go on, go on. We're gonna go Algebra 2. And what? I thought I had. Okay. So, hang on. Just give me a second. Well, here, I'll use my mouse. It's a little bit faster right now. Oh, 1.4, that one. Yes. Okay, so there we go. Bam. Okay, so we're going to solve this one by factoring. So our objective today and our essential question, students will be, no, you don't have to write this down because like I said, we're not turning these in or anything, but students will be able to solve the equation when a does not equal 1. And how can we use factoring to solve this when it's not equal? Well, glad you asked. Okay, so let's practice factoring. Now, one of the things we noticed before when I was writing this out, we did this yesterday when we were doing 1.3. The C term, you have to multiply two factors to get the C term. Okay? The B term, you actually have to add two factors. And they involve the same M and N that you used over here. So it should not surprise you that factoring these guys is very similar to the previous one. Just one slight difference. So let's see how that's done. Now what I'm going to do, I'm going to show you the AC method for this, but I'm also going to show you another method. It's called the guess and check method. So I'll demonstrate both of them, okay? So over here on the left, I'll demonstrate the guess and check method. Alright, so here's where I would recommend using your piece of paper to write both methods, because you're going to probably pick the method that you like best. Alright, so when we're factoring this, we need 4 numbers to figure out.
Which one are you doing?
This one.
The AC method?
Oh, no, I'm going to do the guess and check method. Now, like I said, there's 4 spots here that we have to figure out. 4 positions, or 4 things. And this term here takes the first and third slots. And then this one takes the second and fourth. Now, we have to look for 2 factors, 5x squared. Now, it's very similar to what we were doing before over here. But you might notice that there's only one possibility that you might notice 5x times x. Okay? And what we're looking for are integer factors only. I mean, we're not going to go into fractions and all that stuff. So, since that's your only option for this first term, you may as well just put it in here like this, 5x and x. Okay? You know they take the first and third slots, and there's basically only one option. So, we're already halfway done. How about that? All right, there's one more thing I want you to realize. These two go together, and so do these two. Okay? So, you probably don't know what that means yet, but you will in just a few moments. Okay? Now, let's look at the factors of 6. Now, I think you'll realize there's a couple more options here. We have 6 times 1. We have 2 times 3. And because this middle term's negative, we actually need to use the negatives, right? Because we're going to be adding to get that middle term. So what we'd like to do is we could take negative 6, multiply it by negative 1, okay? And we can take negative 2 and multiply it by negative 3, okay? Now here's the deal. We still have to get negative 17 somehow. Okay, but you have to use this pair of numbers also. You see? This pair of numbers has to combine somehow with that pair of numbers. So, for example, if we took the 5x and we tried to combine it with the 6, we would end up with like negative 30x. Okay? And I think you can realize that if you're adding, you're already bigger than 17 in the negative direction. So this x then would go with the negative 1 and give you negative 1x. And that, of course, is like negative 31. That's too big. Well, so you might try a different combination. This is why it's called a guess and check, because you're kind of just, okay, well, which one does the 5 go with? And which one does the x go with? And blah, blah, blah. And then there's another pair of numbers might actually work. So usually it doesn't take that long to figure out, though, and I'll bet some people have already found the combination. So, whoops, I shouldn't have done that. Okay, I'll redo it here. That's all right. So here we had 5x times x, right? And over here we had 1 times 6 and 2 times 3. And these are negative, right? They have to be negative. Okay, so what if we try the 5x with the 1 instead? You see? Try that one. Well, that would give us 5x negative, right? And then what if we took the x here and went with the negative 6? That would give us negative 6x. And this time if you add them, you get negative 11x. Well, that's a lot closer, but really what we need, though, is negative 17. I think you realize that the 5x and x cannot be paired up with this pair, right? So I may as well eliminate that pair. It doesn't work. There's no way it's going to work. Okay, so now let's pursue the other possibility. We could be pairing things up with the 2 and the negative 3. So, and by the way, normally your brain does this really fast, okay? And you're just thinking to yourself, and in about 5 seconds you just did what I did here, right? You're just kind of thinking in your head. So right now I'm thinking out loud. So now let's see, what if we try the 5 with the negative 2? Well, that would give us negative 10x. And let's try this x with this one right here and pair it up with the negative. That would give us a negative 3x. And that's still not, that's getting closer. So that's 13x. We want to get 17, right? Well, so now you see how this is guess and check?
Yeah.
Now some of you guys are more clever at guessing than others.
Negative 3 and negative 2.
How about you pair that one up with that one and it gives you negative 15x, right? And now let's pair this one up with the negative 2 and you get the minus 2x, which gives you negative 17. And at this point you go, aha, I found the pair and combinations that work. Okay, so now let's go back to this picture where we were factoring, right? Now, I told you before that the 5x, you could just go ahead and put them in there, right? Because you knew there was only one combination, right? One pair of numbers. There's only one possibility. So now the other two. I also told you that these two go together and these two go together, right? All right. Now, do you remember which one went with the 5x?
-3.
It was the -3. So you put -3 here. Make sense? And then that means the other one goes here. And now it's done. You see? Now, you've copied down this example that I did?
Yeah.
Now, let me show you the same problem doing it the AC method. Okay? And then you can decide which one's better for you. To be quite honest, when I learned this in high school myself, it was like 1980, 85 or so. Bam! And so that was quite a while ago, and I'm only 47, so I'm not an old fogey yet. I'm not lying. I have my driver's license to prove it. No, I'm only 47. Bea, did you really say that?
That was the cue.
You guys are in jeopardy of going to math hell for a while, so just...
Well, we play. Next year,
Subscribe.
Okay, so this was when I was in high school, and you know what? They didn't even have this method when I was in high school. So, guess and check. Yeah, it works good, actually. I'm pretty good at it.
No one
And
takes forever.
it doesn't take forever. Please, it's faster lots of times than the AC method. So I'll show you both methods here, and like I said, I think you'll realize it's basically doing the same thing. It's just the AC method disguises it. It's a little bit disguised. You see? So let me demonstrate this now using the AC method. It's called the AC method because you begin by multiplying the A and the C. You see?
Hold on.
You multiply the A and the C. Alright, so that gives us 30. Okay? I always like to draw a little line underneath. Now, we have the same goal. We have to find out how to get negative 17. But you have to find two factors of 30 that give you negative 17. But their product has to be 30. So remember, it's like the m times the n is the 30, but you need m plus n to be equal to negative 17.
Negative 15, negative 2.
You see? Now do you see? You know the answer already because we found them on the previous problem, right? We remember we were searching and we found 15 and 2? Yeah, so you're right. And they both have to be negative. 15, negative 15 times negative 2, right? Now, what happens in the AC method is you start out with a trinomial and then you go to a quadnomial. Now, I made that up. That's not really a math word, but it is for our class, okay? I think everyone knows what a quadnomial is, right? It has 4 terms instead of 3, right? You have trinomial, right? It means 3, and binomial means 2, and monomial means 1. So quad means 4, right? Now, the idea is we replace this term with 2 terms. We just found out the 2 terms. They're right here and right here. Let me do that in a nice cooler color.
Yeah.
There. Bam.
That's just like the same color.
No, it's red on my screen.
Yeah, I get it.
Subscribe.
I went to watch one of your YouTube videos, and like someone was like, "We can't see that color," and I was like, "I can see it perfectly."
See? Yeah, it doesn't project quite as clear, crisp on my screen.
Subscribe.
Well, just trust in me. So now what we do is we write this as a quadnomial. So let me show you what a quadnomial is. 5x squared minus 15x minus 2x plus 6. You see what happened? Before we had 17x here. Now we still have 17x, but we've written it as 2 terms. See, so the AC method makes use of the fact that we're going to factor by grouping. We're going to factor by grouping now. Yeah. Yeah, you did this last year because I did. This is review now.
Okay, go on.
So you now look for a common factor. And hopefully you guys say 5x, right? And really all you really need to do is, what do you multiply by to get what do you have to
X.
multiply by it to get the 5x squared?
X.
And you say, compare it with the 5x here, you say, well, the only thing that's missing is this x. So, okay, so x goes here. And then you look at that one and you say, okay, I need a negative 15x and I have 5x, so all I really need is a negative 3. That would give me negative 15x up here. And the nice thing about the AC method is once you get the first one factored, you know that the second one uses the same factor again. That's a little secret I gave you guys. It uses the same one again. So x minus 3, you just copy it down again.
It's a 2.
But what we do have to figure out is the number that goes in front. You need to have a number here. It's never going to be 0. And you can figure out what number you're going to need because you got to multiply out to get these two numbers back again. And so you're right, Mitchell. You have to get a negative 2 here. Okay, so then we factor one more time. We get x minus 3. And we get 5x minus 2. Now, this method, it takes a few more steps, but you just do the same steps every single time, and so a lot of students like that because they don't have to guess and check. And they just kind of get the answer. I think I'll show you a few more, and you can decide which one's better or faster. You could compare them next to each other, okay?
Nah.
So you guys have that on your notes?
Yeah.
Subscribe.
Let's try this one now. Yeah. Alright, so here's what I want to do. I'm going to capture this and put it on its own screen. Hopefully I'll do that. Put a screen there. And now, let me do this. Watch this. I'll show you both methods on the same sheet right next to each other. I gotta grab my tools and get my capture tool. Partial. You need a partial? Bam. There we go. Alright, now I'm gonna move this into the center. Alright, now let me show you the solution on both of these, and right here I'll do the guess and check method, and over here I'll do the AC method. Alright, now because this is a 3x, I know there's only one option. Okay, and you guys be seeing that the first and third, this has to be like 3x times x, right? And see, so I'm already halfway done. 3x and x. Now, Mr. Russell told me that you're allergic to BS, right? These two go together and these two go together, but these come from the last term. Well, look at that. I only see one possibility, 7 and 1. So you have to figure out which combination works. Now, keep in mind, one of these is negative. Which combination would work with this pair over here to give us 20?
The 1 is negative. The 3 goes with the 7.
Yeah, that gets you up to 21, right?
Yeah, and then the 1
So
is negative.
here's what I like to do. This is what I recommend. I circle them, and I connect them together. The 3 goes with the 7. You see, that would give me 21x. And if I put this x with the 1 and make that one negative, that would give me minus 1x, right? And that would give me the 20x. Now, what I just did here, a lot of people just do in their head. Does that make sense? You're just kind of, you have a little calculator going ka-chink, 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 and it spits out the answer. So, what did we find out? The 3 goes with which one?
The 7
So where does the 7 go?
on the 4th one.
Remember, yeah, the outside two go together. So that means the 7 is here and it's positive. And that means the other number, negative 1, goes here. I'm done. You see? The AC method can be very, this method is pretty fast. And the AC method will give us the same answer, but it involves several more steps. Alright, so now, what's that? Oh. I think you're going to realize that the AC method is just disguised. It's doing exactly the same thing, but it's disguised. Let me move this out of the way. So the AC method, we would multiply these two together, and so we get negative 21, right? Bam. And now we're looking for two factors of negative 21 that give us 20 when added, right? And you say, oh, well, that would have to be 21 and negative 1, right? Are you starting to see the connection? The AC method has its own way of doing this also. But now we replace the middle term. So we write this as 3x squared plus 21x minus 1x and then minus 7. And now we proceed by factoring by grouping. So I'm looking at these first two terms and I'm saying, well, what can I factor out of here? And I say, well, how about a 3x? Hopefully you can see that also. Now what do we be multiplying by to get the 3x squared up here? What's missing? And hopefully you say, not 21, you say x, right? We have to get 3x squared, right? Now what's missing on this one? The 7. A positive 7. Now here's where you can take a little bit of a shortcut. This factor always comes up twice. So just write it down twice. X plus 7 over here. Okay, the only thing that remains here, I think, on this step is to figure out what number goes here.
Oh, that's our bell.
Yeah, oh no it's not. Haha. That's a negative 1x up there, and I have positive x. That's a positive 7, that's negative x. So to fix that, I need a negative 1 here, I think. Everybody got it?
Yeah.
So now you factor one more time. This is the common factor, so you put this out in front, you get x plus 7. And then the remaining factor, after you take this factor out, you take this factor out, what's left? 3x minus 1. Okay, so this is kind of review, but please notice you get the same answer. Okay? Now I'm not sure which one you think is better, but I think we should just do one more for the fun of it, and then we'll do a few more other problems in the lesson.
It's not fun.
Oh, please. I know you're...
It's not fun, honestly. I'm always...
It's super fun. Look at you have a student falling asleep.
Wow.
Yeah, look at Makita, look. Makita, wake up.
I don't care.
All right, let's try number 5 here.
Like us trying it too.
Well, this one is a little bit harder,
Subscribe.
okay? This time you have two options for the first and third slots. Remember, the first and third slots are going to be filled up with this first factor right here, right? And that's going to come down to here and over to here. But look what options we have. I'm going to erase this real quick because I need some room to write. Look, there's two options this time. We could have 4u times u, right? And we could also have 2u. Can you put away your cell phone? Idols. Okay, so this is 2u also, right? But on the other hand, this one's easy because there's only one option on this side, right? 5 times 1. Okay? So, that sign is positive, this sign is positive. Somehow we got to manage to get 12. So, you quickly go through some options here. Like, mentally I'm trying the 4 and the 5 and go, hey, wait, that's 20. That's way too big. So then I try the 4 with the 1 and see if that's going to work. Well, that would give me 4u. And then the 5 would go with the other u. And so I add that to the 5 and I'm thinking to myself, well, hold up. That's 9u. I need to get 12.
I thought we were doing it.
Oh, you can work ahead. Okay, so I quickly realize, hey, the 4u and this doesn't work no matter which way I try it. All right? But if I try the 2u with the 5, I get 10u. And I try the other 2u with the 1, I get 2u. And if I add those two, I get the 12u. And I say,
I can't even see those numbers because I'll put a line.
oh, well, I'll clean this up a little bit. You see, what we were after was 12u. And we ended up getting it.
You won't tell me.
Huh? So, again, these take the first and third slot. So we found the pair that goes here, 2u and 2u. Now, again, these two go together, and these two go together. Now, in this particular problem, these are both 2u's, so it doesn't really matter which one goes with which, but remember, the 5 and the 1 have to be matched up here, and they're both positive. And so, the guess and check method, we're done. That's how we do the guess. Oh, you don't need to clap. Okay.
So can we mark them or mark them?
Well, no, there's much more to still cover in the lesson.
There's much more than
Okay, in addition to factoring new trinomials with,
3x minus 8.
well, I'm glad you got this already. So this is a difference of two squares, and hopefully you know your squares very well.
3x minus 8, 3x plus 8.
Remember, if you have a squared minus b squared, we're going to say it's equal to a minus b and a plus b. Okay, so if this is your a squared, what's a? And hopefully this is the part where you say 3x, right? And if this is your b squared, what's b? You say 8. Okay? Now that you know what your a's and b's are, you can just plug them in right here. It's going to be 3x plus 8 and 3x minus 8. Alright? Remember, there is no middle term. There's like a 0x sitting there. And notice, if you multiply this one times this one, you get negative 24x. But if you multiply this one, you get a positive 24x. And so when you add those, you get the 0x in the middle. And that's why there is no middle term there. I know, that's why I shared it with you. Thank you very much. So you'll have a little bit more complicated problems in this section. That's a minus here. Let's look at a few more of these. These are so much fun. Alright. How about that one? Do you guys recognize that pattern? Well, you might remember from yesterday we had the special pattern. If you have a squared plus 2ab plus b squared, then this factors to a plus b squared. It's a perfect square, right?
Sure.
So you can be suspicious here when you're examining the problem. You go, hey, wait, that's a perfect square, right? And that's a perfect square. And so you have two of the ingredients sitting here already. And so you might suspect, oh, this might be one of those special patterns. But before you jump to conclusions, you need to check real quick, right? Uh-huh. Now, by the way, it's not a bad idea to check this, even though the AC method and the guess and check method would give you the same answer. I mean, you could do it that way. You want to practice doing this because we're going to be factoring cubics someday, and they use special patterns also. So the better you get used to this, you're going to understand patterns a little bit better. So I strongly recommend doing it this way. Let's check the pattern. If this is a squared, then you say a is equal to 2 y. And if this is b squared, then you say b is equal to 5. Then you need to do 2 times. You gotta multiply these two together. And this is 2y times 5, right? You're gonna double the middle term. So what's 2? That's 10, right? You multiply it by 2, you get 20. So this is your a squared, this is your b squared, and this is 2ab. So it fits the pattern. And so now you can say this is a perfect square. And please tell me what goes in here.
2y plus 5.
2y plus 5. How do you know it's not minus 5?
It's not negative.
This here is not negative, right?
Yeah.
It's positive.
Yep.
Okay, so that's the only difference. So real quick, let's do part C. So does this follow the pattern?
Yeah, there's
That's a perfect square. Is that a perfect square?
I'm pretty sure it is.
Yeah, because it's 1 times 1, right? Uh-huh. So, if this is my a squared, a is equal to what? What? 6w, right? And if this is b squared, then b is equal to 1/2. Okay. 1, right? And now, if we try the 2ab part, we have to take the 6w and multiply it by 1. That does equal 12. Okay? So what do we get here? It's a perfect square, right?
Yeah.
And so what do we get? It's the 6w. And 6w,
Minus
and we have a 1. And this time it's minus. And you know it is because of that. Okay? So you're going to have some of those. Now, we're not out of the fog yet, or out of the... We also might have more complicated problems. Let's skip this part and come to this. Okay? Now, you might have to factor out some common factors. So, let's look at this one.
5.
Whoa, hang on, Turbo. I wanted to explain something. I'm glad you're fast and way ahead of us. Here's the deal. Since there's only 2 terms, you might say, oh, well, there's a 0x in there again. And you might say, hey, I know this is a difference of 2 squares type problem, except for when you look at the 5, you go, hey, that's not a perfect squared number. And you might look at the 45 and say, that's not a perfectly squared number. Well, that's a clue. That's a clue that you might factor something out first. And it turns out there is a common factor here. So my friends, please notice that this is 5 times x squared. And notice that this is 5 times 9 squared. 5 times 9. So there is a common factor. 5, take the 5 out, and you get x squared minus 9. Now remember that the common factor is the thing that comes out in front. Okay, there's our common factor. What's so funny?
It's cold in here.
It's cold.
Yeah, like really cold.
I have an extra sweater if you'd like to borrow.
Yeah, pass it
Oh,
this way.
that's so
Well, it's a Napton Viking sweater.
It's
Nice
cold.
subscribe.
Are you sure it's clean?
Until the end of this period.
Oh. It's cold, guys.
Okay, so can we factor this one now? Can you do it now?
That is x squared
Difference of 2 squares, right?
plus 9. That is
That's going to be your 3 squared. That's going to be x quantity squared. So hopefully you're saying x minus 3 and x plus 3, right? That's a difference of 2 squares. So hopefully you realize that sometimes you might have to factor out common factors first. Right? Mitchell, aren't you glad I showed you these?
It refreshed my memory a lot.
Okay, so now notice this one. This might be that perfect square pattern also. This might be one of these guys. Oh, but it doesn't look like it because that's not a perfect square and that's not a perfect square. However, I just now noticed that those are all even numbers. And if they're all even, you can factor out a 2. So if you factor out a 2 here, then you'll end up with 3q squared minus 7q plus 4. Now, that does not look like a perfect square pattern, so forget that. What I have to do now is maybe use that AC method or the guess and check method. Now check this out. I like the guess and check because there's only one option for this one. I know this has to be a 3q and a q. I also know that I need to get to 7 somehow. Yeah, they don't have to be both negative to get that one there. What if we used negative 4 and negative 1? If you put the 3q times q, which number would the 3 go with? You see, if the 3 goes with the negative 1, that gives me negative 3q, right? And if the q goes with the 4, that gives me minus 4q.
Oh, those are good numbers.
They are, see? Aren't they smart? I mean, if you, this would be a negative 7q. That's a q. What's this one?
What?
That's 10q. You're welcome. Eee. Get it? 10q. You're welcome. All right, done.
Thank you. Thank you.
Oh, thank you. That's so funny.
Okay, so again, these two go together. Those two go together. So notice the 3q went with the negative 1, so the negative 1 goes here. And that means the negative 4 goes here. Bam. And then don't forget there's this 2 sitting out in front.
Thank you.
Okay, so that's pretty corny. Alright, so oh, now here's a fun one down here.
Oh my god.
Yeah, you can have a negative for your exponent. You have to
Oh, yeah, there you go. We don't want to have a negative. So let me continue over here. This is negative 5 times z squared, right? And this, what we want to do is, pay attention on this one.
Thank you.
You're welcome. Okay, we want to factor out a negative 5, so how about if we write this as negative 5 times a negative 4z? You see? Because we want a common factor, and we don't want the negative. So if we factor out the negative 5, then what we'd have is z squared minus 4, like that. Oh, now hold up. Wait a second. I need to take a z out also, don't I? Let's take a z out also, because there's a common factor of a z. So let's go back here. Negative 5z. And then what's left? We have z minus what? 4. Okay. And then we're done. There's nothing more to do here. So that one's factored. So, yeah, that's how we can do some of these. Alright, well, let's go back. Now that we're good at factoring, we could begin to use a zero product idea again. Now, the whole reason why this works is because you have a 0 over here. And you have something like a times b over here. You see? And so, keep that in mind. You can't use this if you have some other number.
This is probably going to be your best one as well.
The one that you watched? Yeah.
This is gonna
Oh,
be your
cool.
best video.
Alright. Do you want to do the AC method or the guess
Yeah.
and check?
Please.
AC?
Yeah.
Alright, tell you what.
Okay.
You do the AC, and I'll do the guess and check. I like the guess and check because I know there's only one option for that guy. And so I know that's 3x and x. I'm already half done. Now the only problem with this 8 here is that I have 8 and 1, and I have 2 and 4. And I got to figure out a way to get 10. And so I'm thinking of the 3x times x. I'm looking for which combination works. I guess and check, you just play around and find out which one works. Now because of that negative, I have to subtract to get the middle term. So I want to go somewhere bigger than 10. So check this out. If the 3x goes with the 4, I get 12x. And if the 2 goes with the other x, I get negative 2. And I found out the numbers that work. The 3 goes with 4. And this one goes here. And so this one's what? Which one was my negative one?
Two.
This one's negative, so that one's negative, this one's positive.
Caleb beat you.
Well, I went slow on purpose for your sakes. I could have been done in about 10 seconds.
Oh, baloney.
Oh, you guys have no faith. See, back in 1985, okay, I'll tell you what happened. They had the Apple. This is a true story, guys. Listen. Listen.
Okay, whatever.
They had Apple IIe computers back then, and we would go to the computer lab and practice this, and we'd have contests. And now we had to type in our answers using a keyboard, and we would set the timer like 5 minutes, and our teacher would see who could get the most done in 5 minutes, and we were getting like 40 done in like 5 minutes. I mean, we were super fast at this stuff, and we didn't do it using the AC method. We were doing this so fast in our heads. We were like so good at. I'm not kidding. You guys think you're bad at? I'll show you. You guys want to try another one?
Do it in 10 seconds.
So it was
Okay.
a year later.
Ready?
Oh, now this one we have to do some algebra first.
Wait, let's see how fast you do it. Ready, go.
Well, it's not. We're not ready to factor it yet. But you have to use the principle of zero products.
We'll see who it takes, who can win. You want to win Caleb.
She's gonna be looking forever because she's gonna have 120.
No, it's just 100.
Let's see. I have to look for a while too. Let's see. 10, 2, 4, 5. Let's see. I gotta get. How about if I do a 5 here? That'd give me 20. 5. 4. No, that doesn't work. I have to use a 4. Wait. I gotta use 4, 4, 5. Negative 25, 4. Oh, ha! This is a common factor. No wonder. Take a 5 out first. See? Minus 4. Plus 5. Oh, man, I'm way ahead of you already. 5. I got P. How about minus 5? And P plus. Oh, wait, that doesn't work. Now, my friends, this is prime. There. What's taking so long?
It's taking so long. Okay, Rosanne.
I wasn't even going slow for her, having mercy. I would have been done a half hour if I wasn't using this pad. Is that right? That part doesn't factor, I don't think.
What's your factor of 5 equal negative 4? Why did you get a
can't.
plus 5? It's only 20, not 25.
What if you had a negative 5 and a positive 1?
Oh,
you did it wrong.
I took out a 5, right?
Yeah, but 5
Oh, so this is supposed to be 4.
Yeah, you're wrong.
Oh, well, here I thought. What? Oh, hold up. I'm not done yet, man. P minus 2. And P minus 2. And I got 5 already. And that's P minus 2 squared times 5. I'm done already.
Okay, but I helped you. Out of all people, I helped you.
Well, I just made a mistake. You have to realize it's the first mistake I've made all year. Just calm down already.
It's a prime though.
It's not fine. I'll just be quiet. You guys. All right.
You're still going. I'm still going until.
Give up.
Keep in mind that you might have these revenue problems, and we did one of these a few days ago. And remember that revenue is equal to the number of items, and we're going to multiply that by the price. Okay? And so often on these problems, you're going to let x be equal to the number of $1 decreases. Okay? Or whatever amount they said. Oh, this time we're increasing. Uh-huh. So instead of using decreases, instead you should probably increase. Okay? Okay? Anyhow, And then you got to figure out what's the algebraic expression that describes how the number of items is going up. Okay, so let's look at this here. It says a monthly teen magazine has 28,000 subscribers. And they have that when you charge $10. What if we increase the price and change it to $11? We might lose some customers, right? Oh, in fact, we lose 2,000. I'm not sure that's worth it. Okay.
Oh, subscribers.
So, anyhow, what would happen on this particular... There's my eraser. Huh? You guys better write nice comments when you watch the video.
I am, especially on this one. I'm in it.
Oh.
I'm gonna tell everybody to watch it so I can become famous.
So I think the revenue becomes this. We lose 2,000 each time, right? So the number starts off with 28,000. Okay. And we lose 2,000 times whatever x is. Every time
That's you. Thank you.
every time you increase the price by $1. And so what is the price now? The price is over here, right? The price started off with 10 and you're adding x, right? So that becomes our revenue function. This is the number of items. Okay, number of items. And so what you have to do is multiply this all out, blah, 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 and you get an ax squared plus bx plus c, right? Now, Mr. Russell told us how to find the x coordinate. Remember, this is going to be a parabola, and the parabola either opens up or opens down, and it'll either have a maximum or a minimum. It opens up.
Left down.
Oh, it opens down or up, right? Yeah. So, remember how to find the x coordinate. It's equal to negative b over 2a. Now, I'm not going to go through the whole process. We set the problem up. I'm assuming you guys could all multiply that out and finish it off, right? Okay, so I'm going to stop the Camtasia video. Hang on.
No, sure.
Well, it's hard.